Welcome to a new video in my home automation series, and today I'm going to show you the second board that I built with, using my home sensor board that I designed and manufactured them with PCBWay. And by the way, this is probably like the fourth video in this video series, because there was a video where I talked about how this board is designed and what is it designed for, because I created a lot of different layouts here for different sensors and the way I'm going to use it. And I've already designed a simple sensor board with some temperature and motion sensor. And this board, it is again special because this is going to be designed to power and control an extraction fan. And let me also show you this extraction fan. So I purchased this, honestly, I don't know how to pronounce this. I think this is an Italian make. And it is a type of extraction fan, which, I mean, usually it's installed in the kitchen. The only special thing about that within the housing, there is actually like a ceramic heat exchanger. So in normal operations, it first extracts air from the house, and the extracted air is going to heat up the ceramic heat exchanger. So that it does it for 70 seconds, and then it's going to change the direction of the fan, and it's going to pull in fresh air from the outside, and that fresh air is going to be preheated by the heat that is stored in the heat exchanger. And it basically does this cycle every 70 seconds. So I would be able to change the air, or actually refresh the air within my holiday home, and then hopefully that would prevent, you know, molding and some other things that otherwise might happen during the winter when, you know, we are not really using the house, and also it's not going to be heated. At least that's the plan. So this is why I purchased this. And you can buy like CO2 and what else? A humidity sensor for this device, which can control it automatically. But I thought, well, you know, I'm the guy who does DIY stuff, so I should be able to do that using Node-RED. So that's the whole premise of this video. Well, actually this video is about this control board, which is going to control it. And if I show you the in the manual, well, this is Hungarian as well, but I guess you can find an English manual. The thing about this unit, it has this control circuitry. So there is connections for live and neutral, and then there are connections for 3 switches. I just have to, you know, connect ground. So I thought I need to, you know, provide power or switch, you know, mains power, but this is just simple, you know, ground connections. And if I use these connectors, I would be able to control 2 things. So using the S1 and the S1 switches, if both of them are off, then the fan is off. If the S1 switch is on, then it's speed 1. If the F2 switch is on, then it's speed 2. And if both of the switches are on, it's speed 3. So I have 3 different speed settings for the fan that I can control. And if I also switch in the third switch, then I can disable this cycling mode. So then I can, you know, get air directly blown into the house. So let's say if it's winter and if it's a warmer temperature outside, so if there's a nice warm sunny day, I can just switch it to, you know, just to push air inside. So I can just bring in some, you know, warmer air from the outside to inside. Otherwise, I would use it, you know, just using the S1 and the S2 switches. So then it uses the internal heat exchanger. I think it's quite a clever solution. And because I'm going to have sensor inside and outside, I will be able to compare, you know, temperature and humidity inside and out. And hopefully I should be able to build an interesting, you know, control with this one. So, and this is why this board has a relay board attached to it. I mean, I bought this 4 relay board. So let me just switch back. Like this, sorry. So I bought this 4 relay board. Obviously, I'm not going to use the 4th relay, so I'm just going to use 3 relays for the S1, S2, and the S3 connections. I have populated all the mains power circuitry on this board. So I have the AC power adapters. So this is the high-link mains to 5 volt power adapter. There is a connection here to connect the mains lead. I've also installed a varistor, and there is just a regular fuse. And I haven't installed any sensor on this board because it's going to be in the same room where I already have temperature sensor, and I didn't want to combine it here because of the way, the place this sensor is going to be in. And the only other thing that I have populated is the current clamp circuitry. So the current clamp is here, and it has this jack, so that's going to plug in there. And besides the jack, there are two, I think 10K resistors and a 100 mic capacitor installed. But I talked about all these in the previous video already. Okay, so I have connected the mains part to the power input, and I'm going to plug this in, which means there is no more touchy on the board because there are some live components on the board in various places. So let me connect the plug, or let me just plug into mains. And let me also switch on the socket. Okay, and then probably you could see, or at least you could hear, that some of the relays got energized, and it's not all the relays, and this is important, and I've used a similar concept before. I used relay boards with a VMOS D1 Mini in the past as well, and you just have to remember that in this particular setup, the input 1 and the input 2 are connected to the pins that don't switch states during power up. So if you would use this same setup to control something, for example a garage door, always use either input 1 or input 2, because they don't switch when the unit powers on, so they don't send signals out. I'm going to be connecting this to a fan, so even if it comes on for a short period of time, that just means that the fan is going to turn on and immediately turn off, which is not nice to the motor, but it's not going to do any major harm. And the reason I'm just propping this up because I want to limit the refraction. So now this unit is working, and let me just switch to this side-by-side view. And just to prove that this unit is working, this is connected. So this is sending information on the fan, so /fan topic, and you can see that now it's running for almost 2 minutes now, and I also have some switch states that are coming in, so we can see that it is actually working. You see the updates. So now we can talk about how the YAML file is working. And by the way, everything that I'm showing you here, there is going to be a GitHub link in the video description where I explain where you can download the YAML file, and also you can find a link to the PCB project page where I have a link to most of the components that I used here. So let me go back to the YAML file. To make this work, you need the fan.yaml, and also there is a secrets.yaml. This is where I store all my secrets files, which I share across most of the other YAML files, so my other YAML projects. And it just makes it easy, so I don't have to maintain the passwords and some of the other information in each of the files separately. So first of all, in the document, or in this configuration file, I'm going to use the device name in many different places. So I just created as a variable, and which I'm going to use as a substitute in many different places. For example, right here in the ESPHome declaration, the name is going to be the device name. And this is the platform I'm using, and the board type, which is the VMOS D1 Mini, as you can see here. The next is a standard ESPHome stuff. So there is an OTA section where I have an OTA password. There is a Wi-Fi section with a Wi-Fi and a password. And also there is a fallback API option as well. And because for this ESPHome project, I'm not going to use Home Assistant, I have deleted the API section, which would normally be here in this section in the beginning of the file, because I'm going to use MQTT for this project. I want to talk to this ESPHome device directly from Node-RED. I'm choosing to use MQTT for that. So I have the basic MQTT declaration to declare what's the broker IP, user ID, the password, and what is the client ID. So the ID of this device, for which I'm again using the device name. And next let me just keep this sensor text. Let me just talk about the various sensors. So first of all, I have the current clamp. So this is a sensor type, the ADC sensor. And specifically, this is a current clamp sensor connected to the ADC. So ESP8266 has only one input. So this is A0. That's the ADC sensor. And what you need to do in order to get this sensor to show you actual values, you also need to calibrate this. Because basically what ESPHome is doing here, it's going to measure the voltage in the input pin, and that voltage is getting generated by the burden resistor, which is inside this current clamp, and also by the voltage divider that is those two resistors there. And so that's going to create a value, and that's just going to be a raw value that the ESPHome is measuring on the analog input of the ESP8266. So you need to calibrate it. And I have done a separate video how you calibrate that, and it was quite a long process, so I don't want to go through the whole process again. But basically you take a source. I just use my wife's hairdryer on the maximum setting, and I measured what is the reading, which was 0.096, and I also have a regular current clamp that I measured that on the maximum setting. That hairdryer was drawing 8.1 amps. So basically I just created this linear transformation that for zero reading it's going to be 0 amps, and for this reading it's going to be 8.1 amps. This section is required for the current clamp, and again that linear calibration is going to differ for you. These few lines. The next one is I've also created a template sensor, which basically, the ADC sensor is going to give you current in amps, and I created this template sensor which just multiplies the current by 240. So that's the approximate line voltage. I'm not measuring voltage, and I don't need the proper wattage consumption, but I thought I'd just add this, and I also show you how this is done. So you can just do this with a template sensor and then just provide a lambda function which does the calculation, for example, from other sensors. And both of these, I've created a specific state topic. So state underscore topic, which is the device name / current or device name / power, which you can see here. And these should be, so as you can see, no, it's actually showing 0.0, and the power is, maybe there is some rounding issue. So it shows 0.0 amps and then 1 watt power drawn. And by the way, this is not going to be accurate. It's just going to be good enough for me. So I'm going to measure the current draw or the power consumption by the fan. So at least I would be able to tell if something is not working correctly. So that was all about the template platform to also provide me the watt value. I could have done this multiplication in order as well. The next one is a signal which gives me the Wi-Fi signal strength, so the RSSI. So I can tell that if the device is located in a place where there is good Wi-Fi reception. And I also have a few things which does the uptime calculation. So there is an uptime platform built into ESPHome, which is going to measure the time since the unit was powered on. And normally it measures in seconds, but I wanted all this in minutes. So I added these few lines here which says filters, and again I use the lambda function, which basically divides the value, which is the second value, by 60. So this is how I get the minute, and I also change the unit of measure to minute. And there is another lambda, there is another function here. So when a value is generated by this sensor, there is this, this is a lambda function. So there is this calculation which calculates the second values into a human readable format. So you see the uptime is 10, as in 10 minutes, but actually it is 9 minutes and 42 seconds. Maybe this is some rounding here. And so that's all about the clamp sensors and some of these other uptime things. Oh, by the way, what you probably also see here, that this lambda function updates the the text underscore sensor, which is defined here. So this is not a sensor type. Oh, okay, so this is a text sensor that you have to define, which is just, it contains some text, which is getting updated by this lambda function here. Okay, let's move on. And last, I have to define some the inputs and the outputs as well. So I have a header here at the side here, which is specifically designed for these 4 relay boards. So it contains the ground, the 5 volts, and the in1, in2, in3, and in4. I made one mistake with this connector, because if I look at this relay board, then I have ground in1, in2, in3, in4, and VCC. And then on in my board, after ground, I have in 4 and 3 and 2 and 1. So I had the inputs the other way around. So what I have done in the YAML file is, if I follow the route correctly, then in 1 should be D0 and in 2 is D1, and then D3 and D4. So basically I just switched the declaration here just to match the reverse connection on the board, well, between the board and the relay board as well. So at least if I'm operating in 1, that would operate the in 1 relay, or the relay 1 on this relay board. So at least the sales screen is going to match with what I send to the device. And as you can see, I haven't specified any state topics here, because it's an input-output device, the GPIO, so I would anyway have to supply a state topic and a set topic. So I just said, just don't bother with it. And then if you are not specifying these topics in the YAML file, then ESPHome is just going to generate some standard MQTT message structure for it. So as you can see, it now says switch in 1 and then the state, which is either on and off. And since we are in the MQTT Explorer, let's look at how we can turn on this relay. And I actually forget what the topic is. So as you can see, I was playing around with it. And it is fan/switch/in1 or in2 or 3, and then /command. And to that command, you send either on to turn that relay on. And you can see in1 turns the in1 on, or you can turn it off. And of course, you can do the same with any other switches or any other output as well. And by the way, a couple of minutes ago, I told you that because when the ESP boots, it's going to pull the input 1, and it will not pull input 1 and input 2, but the way it is connected now with a Philip cable, it is actually input 3 and input 4, which is now going to toggle when the device boots up. So again, just keep it in mind if that's important for your application. So just to recap again, the topics for the various inputs that are defined as, where is my thing? Yeah, so the one that I defined as a GPIO is going to be the base topic, which is the name of the device, /switch, and the name of the GPIO, and /state is going to be the actual state, and /command, where you send on and off, or on or off, it's going to toggle the output. Maybe there is a toggle command as well, but to be honest, I'm just going to use on and off all the time. So this is how you control the 4 outputs, and how you use it in MQTT. And finally, I've included one more section here because I always like to have a web server for all my ESP devices. And if I remember, the IP of this device is 182, and it is not 182. So I need to figure out what the IP is. And I usually use an application. Well, for Android, there is an application which is called Fing, F-I-N-G. Maybe there is the same for iOS as well. And with that, I can scan devices, and I think it should be 180 something. And if I just open the device or the IP of this device, which is 144, then I can see the web server of the fan, which, it just gives me information about this device, and you can also see the logs here, so the debugging logs, and you can also toggle the inputs from here. So if I want to make changes here, I can do that as well. But again, I'm only using this for sort of administrative purposes, because if I see a lot of IPs, most of these devices are on the HCP, but I might just change them to fixed IPs. So at least if I just point the browser to the IP, usually there is a web server behind it for all the devices that I create, so I can tell which one is that. But with this, we got to the end of the YAML file. Well, this is what I've configured for this device. If you are interested in this, or you want to build something similar, or you want to use parts of this YAML file, you are going to find the GitHub link in the video description. Also, there is a link to this PCBWay project, just as I said in the beginning. But I think that will be all for today. Thanks for watching, and hopefully see you in the next video.